Hey, my name is Ben. Thanks for stopping by. In this video, we are talking about mini splits and specifically having a multi-zone mini split where you have different areas that are controlled by the same outdoor unit. Now, the outdoor unit that we're using is a hyperheat unit, meaning that it can heat all the way down to 22 below zero, which is really important because we actually live up in an area where we do get those sorts of temperatures. We are in Minnesota, so the wintertime lows can be even colder than that on rare occasions, but most of the time, 22 below zero, it's going to be slightly warmer than that around here, thankfully. Now, originally on this project, we were just going to have 3 different head locations, just standard wall mount units. However, the owner of the property asked if we could provide some conditioning in the bathroom space. The building that this is going in is kind of a purpose-built shed, so there's some areas that are conditioned and some areas that are not. But yeah, he wanted to have some conditioning in the bathroom. Now, the issue is you can't really hang a indoor unit in a bathroom specifically. You really don't want to do that if at all possible. We needed to figure out a way to get some ductwork or something into that bathroom. And the cool thing is that Cooper & Hunter, which is the company we're working with on this project, is able to provide you an air handler unit that connects to your outdoor unit much the same as the other standard wall units. It actually wires up exactly the same, and you run a LINESET to it the same way that you would with a standard wall unit. However, you take and connect that air handler unit to ductwork instead of just having it hanging on the wall. They do also offer some other types of indoor units, so I will link to those in the description as well, but there's basically some slimline duct ones, some cassette units, floor mounted units. There's a bunch of different ways that you can actually utilize these. You don't have to use the standard wall hung unit. But we are going with this air handler unit. This thing is really fantastic in the sense that it connects to traditional ductwork just like a lot of the units that are already existing in the United States. This also makes it a good option for retrofitting if you're going to have multiple new zones with mini split heads, but then you want to integrate existing ductwork. You can do that by using an air handler. Now, obviously, before you get started on any project that involves HVAC equipment, you want to know what you need for your heat load. So do a heat load calculation using a tool like coolcalc.com or something similar to make sure that you're getting the proper sizes of each unit. The air handler that we're using is a 24, which means it's a 2-ton essentially amount of cooling or heating that it's able to handle. So for this installation with our 3 different indoor units, the 2 wall hung units, we have one that is a 9,000 BTU, one that's 12,000 BTU, and our air handler unit is a 24,000 BTU. With these outdoor units, it can handle multiple different zones. They actually give you a chart and can tell you exactly what combinations of inside units that you have. Obviously, you couldn't have 4 zones that are each 24,000 BTU if you were going to just use a 36,000 BTU outdoor unit. And if you add up those numbers of the inside units, they don't necessarily have to exactly match the total capacity of the outdoor unit. They just have to be within a range that is specified by Cooper & Hunter. So keep all that in mind when you are ordering your equipment. Links are in the description to the different items that are in this video, as well as some other possible configurations that may be useful for your particular situation. I will also link to the different tools and any other accessories or things that you need down there, so definitely check out the links. I do my best to put a lot of really useful information down there. Now that we have all of our equipment choices figured out, we are ready to talk about the actual installation, and we're going to start with the setting of the outside unit. Now, there's multiple different ways to do this. Whenever you're going to do a heat pump and you're in a northerly climate, you got to make sure that it is up off of the ground at least a little bit above where the anticipated snow accumulation can be. Now, we actually had an absolutely crazy winter and a huge amount of snow accumulation this past winter, which really reminds me that keeping the unit up above that is really, really important. And actually, we had a few different places where the snow accumulated so much that it did damage equipment and especially heat pumps, just because there was no way for the snow to get out of the way for being able to have proper air ventilation through that unit. So with this one, we decided to mount it 14 feet off the ground. Actually, I'm not exactly sure how high it is, but it's something like that. But actually the main reason is that we just needed to get it out of the way so that this entry to this part of the building wasn't affected by the unit. There just wasn't a great place to put it, so we put it up super high. And this actually created an interesting scenario where the unit has less clearance above it than is recommended in the instruction manual. And I did clear this with Cooper and Hunter just to kind of ask them about it, and apparently it's actually not that the unit won't function properly, it's just for serviceability, having a little bit more space above it would have been really nice. However, this was the best we could do, and it ended up working out really well. Now, for mounting a mini split on the wall versus on the ground, there are a few considerations to take into account. The first one is that the outdoor unit does actually produce some vibration, as probably is obvious since there's a compressor inside of there, and that can transfer through into the inside of the building. So if you want it to be absolutely silent, hanging it on the wall is actually probably something you want to avoid. The second thing is that the wall brackets that are available, like if you purchase mini split wall brackets, and I've actually tried to use them before on another project of my own, they are just very inadequately built in my opinion. It seems like something that should be very solidly constructed and not be like just barely strong enough to hold the unit. So we actually custom fabricated some brackets out of some heavy duty 1/4 inch thick tube steel or similar to tube steel, and I would recommend doing the same thing. The nice thing about doing it this way is you can actually weld them up strong enough where you don't even need the angled piece that is going to be the additional support bracket or whatever for that L-shaped piece. And so I was able to make a really clean looking bracket that also didn't affect this entry point to the building. There's kind of an area where you could like drive a skid loader through or something, so we wanted to get it up and out of the way as much as possible so that the unit wasn't going to get hit or hooked on or anything like that. The unit is actually really protected from wind and bad weather just because of where it's located, so it all turned out very, very well. And at the end, I'll talk a little bit more about the vibration issue and the noise coming through into the building from the unit running, because obviously you really don't know that until after you get the unit installed. Now, as I mentioned already, we have two standard wall units, one of which is actually a pretty long run. It was like a 50-foot line set almost exactly to get to where it is located, and we just externally mounted that line set since it wasn't really a problem as far as aesthetics go in this particular installation. But there are multiple different ways to run a line set. You can go through the attic, you can even go through the walls if you really want to, but this ended up being the best option for our particular case. And that 50-foot line set was going over to the 9K unit in that more remote room. The second wall hung unit was kind of interesting in that it is like directly on the other side of where the outdoor mini split unit was mounted. And the interesting thing about that is that we could have gotten by with as little as 4 feet of line set, which at first sounds good, but actually that is not a good thing to do. You actually want to have a minimum of 10 feet of line set between where the wall unit is hung and where the outdoor unit is located, a minimum of 10 feet of line set. So what we had to do is actually create a loop of line set right outside next to the outdoor unit in order to prevent that line set from being too short. Now, the third location, of course, is going to be that air handler we talked about already. Now, we sized up the ductwork, and I've talked about ductwork sizing, so I'm not going to go into too much detail here, but we have a supply and a return that is large enough to handle that 800 CFM of airflow that's needed for a 2-ton inside unit. And for those of you who don't know already, 24,000 BTUs is equal to 2 ton. So it actually comes out to be that 1 ton of cooling is 12,000 BTUs. And for those of you who are even more curious, I believe that the way that they came up with that 1 ton term is that 1 ton of ice, if you were to melt that, that amount of cooling that it provides is equal to that 12,000 BTU. So really interesting how they come up with all these random numbers, but they do have a reason, just that they didn't translate into the modern world quite like we maybe expected. So we got all that ductwork sized up and ran. We have ductwork going over to an office area, so supply ductwork and return ductwork to that area. And then we have just a supply duct going to our bathroom, because generally speaking, you don't really want to run return lines from bathrooms. Basically, that room will be slightly pressurized from that air vent, but that's a good thing. Extra air coming into that room is going to be vented out through either the bathroom bathroom fan or just out through gaps and cracks in the structure itself, which is not really an issue, and it keeps the bathroom much fresher, and then you're not pulling that return air back into the rest of your building from the bathroom, which is where you don't want to be pulling air from. Now, we did actually run a couple of vents into the mechanical room just to keep the humidity lower in there in the summer so that we don't have too much issue with sweating on water lines and things like that. And then there is a little bit of ductwork going into the shop area, which is kind of bonus and not really its intended purpose. But if there were a unique situation where you wanted to dump the cooling off, that 24,000 BTUs would be available to the shop. That's going to be disconnected or shut off the vast majority of the time, but we just installed it so that the possibility is at least there. Now, we'll briefly go over the electrical aspects of this project. I did not personally do the wiring on this particular job, just because there was an electrician that was already tasked to do that. So let's go ahead and go through the different details that you need to know. The first of which is that most of these outdoor units are going to be 230 volts, or 208 230. Now, the size of the circuit that we ran to this particular one, the minimum is 40 amps, the maximum fuse or circuit breaker was 60 amps. So a 40 amp circuit at 240 volts should be adequate for this particular outdoor unit. Now, that's pretty much the only thing you have to worry about when it comes to a main power source, because from here everything is distributed to the different units inside via a 4-conductor cable that is included with the line sets. Those 4-conductor cables are really straightforward to hook up both in the outdoor unit and the indoor unit, just because they are numbered, and you just have to line up the colors, make sure that they're hooked up the same on the inside and the outside, and you should be good to go. Now, each line set is marked either A, B, C, D, so on and so forth, and the sets of wires on the outside unit are marked similarly, where they're marked A, B, C, or D, and so you just have to make sure that the line set and wires corresponding to that line set hook to the correct spot for that particular indoor unit. The only other wiring detail that is involved is that we did actually pull a thermostat wire from the air handler unit to the office, which is what will be controlling our air handler. Now, they do offer different wireless solutions as well, so if you are interested in having more of a traditional remote style, I believe there's a way to make that happen as well. Personally, for an air handler, I would rather have a regular wall-mounted thermostat anyway, and so that's what we went ahead and did. The included thermostat actually only needed 2 wires to communicate back to the air handler, even though it has a whole bunch of different functions that it is able to perform, which is pretty cool. However, I did go ahead and have the electricians run a traditional 8-conductor thermostat wire over to that location in case there were ever to be a change where a traditional heat pump were to be installed in place of that air handler. You would be able to go ahead and hook up a traditional thermostat. Some of those future-proofing things are just worth doing, even if it takes a tiny bit of extra material in the short term. Some of these units do have a feature called Follow Me with their remotes, where it uses the temperature sensor in the remote controller instead of the temperature sensor on the wall unit, but by default it'll actually just sense the return air temperature coming back into the top of the unit, if I'm not mistaken. If this video has helped you out so far, I'd really appreciate it if you consider smashing that subscribe button down below in exchange for the work that we put into this video. I would really appreciate it. Also, feel free to comment down below with any thoughts or suggestions that you might have, or experience that you have on mini split installations. A couple other details with the ductwork are that with an air handler unit, you're going to have a dedicated filter. This one is no different in that we have a 16 by 20 filter that is able to be installed on that air handler. My recommendation on air filters is that you should buy the cheapest pleated air filter that you can get your hands on. Don't buy the really expensive ones that are with a really high MERV rating, like a MERV 12 filter, because it's as if you're putting a plugged filter in right away. If you want a high MERV rating filter, you need to get a filter rack assembly or whatever that is going to be for like the 4-inch filters, the really thick ones, so you can get more surface area so you don't mess up your unit with excess static pressure. Also note that codes vary in different areas with the ductwork and the way that you install it, so always check with the authority having jurisdiction. Some jurisdictions or areas require that there be a disconnect located inside of the room for that unit. Obviously, since we're powering this thing from the outside unit, we are actually not able to just turn the power off right inside of this mechanical room here, and so sometimes adding an additional switch or a means of disconnect on those conductors coming to the unit may be necessary. Alright, let's talk about running line sets. Probably the most fun part of the job. Haha. Running the line sets is super important, and you just gotta pay attention and take your time. Just pre-plan your route and don't force it. That's kind of the main thing to think about. Whenever you can, like if you're drilling holes through the outside wall or other areas, try to angle the hole slightly towards the direction that you're planning to bend the line. It just makes a really big difference. And then you also want to bend the line as much as possible while the line is not in the wall or not in the hole that you're trying to bend it through. You just want to pre-plan as much as you can and just do the best job possible at making sure that all the turns are as gradual as possible. Now, depending on the length of the line set that you're running, there's a possibility that you may need to add additional refrigerant, especially if you're going beyond 50 feet for each one of the line sets. All that information is covered in the installation manual, but just keep that in mind. I did have to splice one of my lines in the middle, and I actually chose to do that by brazing the line together. Personally, I am really comfortable with brazing. If you haven't done much brazing previously, then I probably would recommend just going ahead and doing a flare fitting. Whenever you have fittings that you are connecting, you really want to make it so that those are accessible for inspection, especially on the initial installation, but preferably long term, if you have any issues, it usually comes down to connections. And so having the flare connections or even the brazed connections accessible, if at all possible, is a great plan. Once you get your line sets routed, you're going to have to make the connections on the ends of the line set, and that is done via flare connections. Now, flares can be really tricky, but not really if you pay attention to the essential things you need to know. The first of which is that most of the time the factory flares that come on these line sets are absolute garbage. I've covered this before in other videos, but generally speaking, if you use the factory flares, you're probably going to have issues, so just plan on cutting them off. If you inspect them and they look perfect with no imperfections on the face of the flare where it's going to be coming into contact with that brass fitting, you might be good to go, but most of the time you're going to want to go ahead and just cut them off and redo them. The slower you cut it, the less of a burr you're going to create inside of the tubing. So I'm just tightening it a little bit at a time. When you can feel it starting to get close, instead of cutting through the rest of the way, you can kind of just push it to the side, like that. Now we can remove the flare nut that came with this line set, and then we'll get the flare nut that came with the mini split. Now that our flare nut is in place, we are ready to deburr the inside of this pipe. Now you can use a deburring tool, or you can even use a knife to kind of carefully remove that burr on the inside of that pipe and make sure that the burrs don't fall into the pipe. It actually works really well to just use a needle nose pliers as a reamer. That's basically going to push that burr to the outside, and once we use our flaring tool, it will totally push that burr to where it's completely irrelevant. So I'll just gently push in and rotate, and it's gonna spread out the lip of the pipe just a little bit. Now that we got the inside of our copper tube reamed out, we're going to go ahead and clamp the 3/8 size over the end, and we want to let that extend out just a tiny bit. Here's the official recommendation for 3/8. They want it to be anywhere between 1 millimeter and 1.6 millimeters above the face of the tool. So now that we know that, we can look at this, and we want it to be 1.6 millimeters at the most, which comes out to be kind of close to a 1/16. Right about there looks good. Now we're going to slide the rest of our flaring tool over the spot where we want to create our flare, and you can see this little arrow should line up with this line right here on the flaring tool so that it can clamp down properly. So we just tighten it and just make sure that there's no gap right here between the two halves of the tool. Now we're ready to tighten down. See how it kind of rolls around in a circular motion? That is what allows this thing to make a higher quality flare than a standard flaring tool, which would normally just mash that cone right down into the end of the pipe. And that's it right there. We'll back it off, loosen the clamp, slide this back, open up the tool, and there we have our flare. You can see on the very outer edge of the flare, the copper is cracking a tiny bit, and that's not really a concern at all. As long as your flare nut goes over the top and rests properly, it's going to be perfectly fine. So this one's good to go. Let's go ahead and do our second flare fitting. Take our tubing cutter and cut back just far enough that we're past where the previous die had squeezed down onto the copper. We're going to take off our factory flare nut that came on this line set and replace it with the nut that came with the mini split. And take our needle nose and remount the inside. That's adequate, and I can feel this with my pinky. Make sure that there's no burr left. Now we'll take our flaring tool, and according to this chart, they want it to be anywhere between 2 millimeter and 2.2 millimeters, so right at around 1/16 of an inch. Pretty much just eyeball that height. Let's go ahead and make our flare. Made contact right about there. Now we'll back it off. We can see that the face right inside of this flare is really nice and smooth, and that's the spot that matters. That's where the seal is made between the copper pipe and the brass fitting that it connects to. Here's the difference between the factory flare that I'm holding in my hand here and the flare that we just created. You can see that there are a few more imperfections in the face of the factory flare than we have in the flare that we just created. And you can see what I'm talking about with that burr. By reaming this with the needle nose a little bit, it pushes that burr out enough that when you flare it, that burr stays to the very outer edge and it doesn't get rolled over onto the inside. Here's the comparison of the factory flare on the smaller line versus the flare that we made. That little bit of coating right there on the flare that we made was from the needle nose. There was a little bit of clear coat on there that rubbed onto the copper. Shouldn't really affect the flare whatsoever though. Now when you make a connection to the actual unit or any of the flare connections that you're making, you'll want to use a little bit of Nylog blue. Now this stuff is compatible with R410A oils, and that's what's important, and you're just going to use a tiny little bit of it. It's almost like the consistency of honey, and the benefit to this is that it makes your fitting go together a little bit smoother. There's going to be less binding between the copper and the brass as you connect it, and it just does a really good job of making sure that you get a leak-free connection. It's not so much of a sealant, but rather more of a lubricant, and it's a really useful product. So link in the description, you can get a bottle of that coming if you don't have some already. Now when you tighten your connections, you're going to want to torque them down to the specified torque rating, which is located in the installation instructions. And when you do that, you want to torque it to the spec and then loosen it and then torque it again. And by connecting it twice like that, it really helps the flare just to conform to that fitting a little bit better and reduces the chances of you having a leak. So repeat that process as many times as necessary until you have all of your line sets connected, and then we are ready to move on to pulling the vacuum on the system. Now for this particular unit, it was really nice the way this one is designed. We can just pull the vacuum on a single port on this outside unit. We don't actually have to pull a separate vacuum on each line set individually. We can pull them all together, but refer to the installation instructions because your unit may be different. You may have to pull a separate vacuum on each set of lines versus being able to pull the vacuum on the entire thing. If you have a standard set of gauges, you're probably going to need to purchase an adapter to these mini splits. They do not use the standard 1/4 inch flare style connection for accessing the system, so I will link to those adapters in the description below. I will link to the different gauge manifolds that I recommend, both a digital and a standard set, as well as a vacuum pump in the description. Now, can you get by with the cheapest vacuum pump and cheapest set of gauges known to man, that you can buy all of them for 30 bucks on Amazon somehow? Maybe, probably, but this is definitely the most crucial part of the entire process, so you have to just decide what you're willing to take a risk on. So choosing slightly better equipment is definitely advisable in my opinion. And this is probably the most frustrating part of the process for me sometimes. Pulling a vacuum can be really finicky, and it seems like you can never really achieve that perfect 500 microns like the manufacturers often suggest. Now the interesting thing is it doesn't actually talk a lot in the manual about the exact number of microns that they want. I did talk to Cooper and Hunter, and they did say 500 microns just like all the other manufacturers. But what I generally find is that getting it to 500 microns can be really tricky, and a lot of times you don't even know if you're there or not. If you're using a regular set of gauges, you're only going to be able to see that needle down in a vacuum, and you're not going to be able to see how many microns it is anyway. So when you hook up your gauges, you're going to want to take the yellow hose and connect that to your vacuum pump. And then the blue and the red hose, the high and the low side, oftentimes you can connect both of those to a traditional system while you're pulling a vacuum. This one was set up more so to just pull a vacuum on the low side by itself, and we could have just done that with just the blue hose, but I actually decided to hook up both the blue hose and the red hose just as two separate ports on the low side. There aren't really access ports to the high side as much on a mini split, because it's not really designed for you to be able to just like throw your gauges on there and check the pressure. The system is more sophisticated than that, and if you lose some refrigerant, you're probably going to have to actually take all of it out and weigh it back in again. I chose to connect both the low side hose and the high side hose to the low side of the system in order to be able to pull the vacuum a little bit faster. So once the vacuum pump is running, you open up both the high side and the low side valves on your gauges, and it'll begin pulling the vacuum down. As the vacuum gets lower and lower, you'll notice that the sound of the vacuum pump will oftentimes change, and you'll notice that it kind of goes from a louder sound usually to being a little bit quieter as all the air has been removed from the system. In my opinion, you want to let this vacuum pump run for at least a half an hour, but it's fine if you let it run even longer than that. Up to an hour would be totally fine by me. After your vacuum pump has been running for that half an hour, you'll then be good to go to shut off the high side and low side valves on your gauges and then shut down your vacuum pump. Now hopefully your hoses have valves on them, because you would want to turn the valve off on the vacuum pump actually if possible, but if not, it can still work. Just keep it in mind that if you're going to buy some hoses, it's a really good idea to buy some that have valves on them. It just makes your life a lot easier in a lot of situations. But that's a topic for another day. Once you have the valves turned off on your gauges, you're going to let the system just sit there. If you have an analog gauge, you're going to want to go ahead and take a close-up picture of where the needle is sitting in a vacuum. And with a digital gauge, it'll actually tell you the exact amount of vacuum that you are in, which hopefully is going to be less than 500 microns. You'll then want to make sure that that vacuum holds for probably at least 15 minutes, but if you have an analog gauge, I would recommend much longer than that. I'd probably say more like an hour to 3 hours would probably be better, because it's a lot harder to see if anything is happening on an analog gauge than it is on a digital gauge. And generally speaking, just for your knowledge, on a digital gauge, once you're looking at the microns, you usually can't pull a vacuum below 2,000 microns if you have like an actual physical leak that air is coming into the unit. You'll just never even get below 2,000 microns. If you're able to get it down under 1,000 microns, but then it climbs back up into like the mid thousands, you probably have a little bit of moisture in the system, and you're going to want to pull that vacuum again and possibly put some dry nitrogen back into the system and then pull vacuum again. By doing that, you kind of are able to absorb the moisture out of the system and get that micron level to drop lower. Now, in my opinion, if you get it pulled down below 500 microns and it creeps back up to like 700 and something, that is fine. I have had no issues with that, and getting it to be below 500 microns and hold that for 15 minutes is very difficult. And you can comment down below if you're a fellow HVAC person, if you're always able to pull your vacuums down to 400 microns and they hold there for days on end, then that's incredible, and I want to know your secrets. But in all the units that I have installed, I have had a very difficult time getting them down to that level, and I know for a fact that I have no leaks. I think that there's a certain amount of off-gassing that can happen with some of the different O-rings and seals and components that are in the system that make it really difficult to achieve that 500 or sub 500 micron level. But comment down below if you have any other thoughts about that. But if it stabilizes around 700, then I am totally fine with saying this system is absolutely leak-free, and we are good to move on to opening the valves. The instructions will tell you exactly how they want you to do this. Sometimes there's a particular sequence that they want you to go through, but typically it's just going to be a matter of opening the high side valve, and after that is fully opened, then opening the low side valve, and then make sure all of the caps are in place and tightened over those access valves. On this particular unit, most of the valves were already open. I just had to open the two primary valves on the outside unit, and I think that that's all. Maybe I had to open them on the air handler unit as well. But just make sure all of the valves are properly opened, and then we are ready to move on to the system startup. Obviously, it's really not a good idea to start the system if any of the valves are closed. On the wall-hung indoor units, there are not valves that you have to open. It's just a matter of connecting your line set. Note that you should really install a surge protector with every mini split installation. just so that you have extra protection against surges. There's a lot of sensitive electronics inside of a mini split, as you guys have seen. Finally, you want to make sure that all of your condensate drains are ran properly. Now, with the wall hung units, I would highly recommend, if at all possible, make that condensate drain run directly out of the unit, like straight out the back and outside, or as close as possible. I really don't like having to run the condensate drain to the opposite side of the unit and then out. Sometimes you can actually switch which side that the condensate drains out. You can like pull a plug and switch it over so it drains out of the left or the right. So definitely check that to make sure. And I guess that's something I didn't mention earlier either, is that you want to drill the holes for your line sets at a slight downward angle so that you are able to have the condensate drain away effectively and you don't get water running down the wall. For the air handler unit, the condensate drain situation is a little bit different. In our case, we are using 5/8 vinyl tubing, so this is a 3/4 by 5/8 barb fitting that we adapt to, and we like to use this type of material just because you can easily inspect it and disassemble it in order to service the line. So if you need to clean this line out, you can just pull this off of here and blow air through it or whatever. And then you'll see right over here, we have this T, which is acting as a vent, and we've got this held up off of the floor a little bit. And the reason for that is that we need to create a trap right on this side. This cabinet is negatively pressurized on this side because the fan is up here. So the fan is pulling the air up, which creates a negative pressure down in here. So you need to have a trap in order for this to drain properly. So that is accomplished by simply holding this up a little bit, and then from here on out, we can vent it, which is gonna prevent this line out here from becoming airlocked. Like I said, you can do this with like 3/4 inch PVC if you prefer to do it that way. But the other benefit that we have in this situation is that since the air filter is right here, to be able to remove this and replace it, we're gonna have to actually just pull this vinyl hose off of here. So it's gonna work just fine in this situation. If this were rigid PVC, we'd have to figure out some other way to make that happen. Either make this go over and down, which could be a possibility, but this is gonna work just fine. The simpler the better in a lot of ways, just for less places for the line to get plugged or to have issues with. So before we start the system, you want to just go down the list of things that were involved in your installation, like the wiring, all the ductwork, the line sets, making sure that all the fittings are properly tightened, making sure that the valves were all opened properly after you pulled your vacuum, and all the condensate drains are ready to go. Then you are ready to finally go ahead and start up the system. For this project, the system startup went completely without a hiccup at all. Everything came on and worked just as we expected it to, and we just had to monitor and make sure that all the condensate drains and everything were working properly. Now this is when we were able to observe the sound level coming in from that outside unit hanging on those brackets, which I wasn't really sure what to expect, but I was absolutely amazed at how unbelievably quiet that outside unit is. You almost can't tell that it's running on the inside, even though it is a wall-mounted unit. Now there are rubber pads underneath the feet where it sits on top of those outside brackets, and that does reduce vibration quite a bit, but it just seems like the unit is very well balanced and just doesn't make that much racket in general. So I was really happy to see that as we turned the system on for the first time. So thank you guys so much for watching. I really appreciate it. If you found this video to be helpful, smash that thumbs up button. Subscribe down below for more videos like this one. I'll put a couple videos here on the screen for you guys to choose from that are related to mini split projects, and we'll talk to you guys in the next one.